Hi everyone. In the previous video, we just discussed about Maven, and now in this video, we're going to discuss about the same project with a different build tool, which is a Gradle. So, as I mentioned in my previous video, in case if someone is not watched my previous video, I would say please do watch. I think that's having a lot of information about the very basic initial setup and the stuff. It'll be definitely helpful. So now this is a kind of, I would say, it's a part two where the same Java project, whatever we build using Maven, now we are going to build using a Gradle. So for that, in my VS Code, I already have a Gradle plugin installed. So uh, once I installed, I will be having an option here. You can just drag and drop, or you can just right click on the build.gradle. If you see, if someone says it's a Gradle project, you should definitely see a file called build.gradle. It is same like pom.xml for Maven. For build.gradle, for build Gradle build tool, build.gradle is a kind of mandatory, I mean default file. Of course, this can be changed as well. I would say for now it's a build.gradle is the default file, and I do have some settings.gradle as well, and also gradle.bat and gradle.w. So Gradle W is something you see here, these two files, Gradle W and Gradle W.bat. I don't need to install Gradle in my local system. These two files will pull the Gradle directly from internet into my local system, and it will make it whenever I say I want to build it, it will download it to my local system, that specific version, whatever the version we mentioned, and it will install and it will compile the project and generate an outcome. Next time when you run it again, it will check whether you already have installed or not. If it is already installed, it doesn't reinstall again. So that's how it works. Same thing for Maven as well. If you see Maven W, so Maven W is basically a wrapper, W representing a wrapper, so which will download directly from internet and it will install in your local system, right? So currently I have a Gradle wrapper and also Maven wrapper. So if I open a command prompt, I don't have a Maven command installed in my local system. If you do mbn hyphen version, I don't have. If I do Gradle hyphen version, I don't have installed. In case if you want to install it outside of the project, feel free to install it. And in case if you want any help on that, please do comment. I'm happy to help and get it installed outside of the project. So there are some advantages of using a wrapper. So let's say a real-time use case where developer A, let's take a scenario where I'm going to kind of explain in a diagram where developer 1 and we do have another developer. This developer is both of them working for the ABC organization. So if both of them working on the same code, if they're both of them working on the same code, assume that they have laptops, and on their laptop they are doing their own development. In their laptop, they can just go and install, uh, say, they can install Gradle or Maven, whatever they like, Maven slash Gradle slash Java, right? So let's say Java 17 they installed. We told them to install Java 17 and Maven, and everything is same. Like, I mean, say we told to run the project, we need to have a Maven. To run we need to have a Java or Gradle, whatever it is. But it should be a specific version rather than using a different versions. So the advantage of using a wrapper is you are running it from the project. You are not running it from you are not using Maven from the local system. So you don't install anything in your local system. So you are directly taking the project code. Within the project code, you already have a Maven. So as long as you have a JDK or Java 17 version, it is fine. So in case if you're not using a Maven wrapper or Gradle wrapper, what happens is you need to install Maven and Gradle. So there could be the cases where developer A using a version 1.2, developer 2 using is 2.2, developer 3 might be using a different version. So there could be some kind of conflicts. There could be some cases where some kind of incompatibility issues as well. So that's where we try to avoid as much as we can. So that's where Maven and Gradle sitting inside the project itself as a wrapper so that we don't need to install anything on our local system. So what kind of version it installs and everything, I'm happy to take a video on that, how the wrapper can be installed. For now, as the Gradle is build.gradle is available and wrapper is available, so now I'm going to use this the extension what is on the VS Code on the Gradle. You see, if you expand this, you can see these tasks, or you can directly right click on the build.gradle and you see there is an option here which I can't see now. Let me see. I can find Gradle. Yeah. So show Gradle task. If I click on it, it will show these are the tasks. So either one of the option, you can directly click on that elephant sign what we had, the Gradle sign, and it will, or you can drag it here. It will show. If not, you can directly right click on the build.gradle and see show Gradle tasks. In majority of the cases, either people won't use multiple at the same time. Just for your learning purpose, I installed both Maven and Gradle together. In real use cases, you won't either you will have a Maven or Gradle. So you, yeah, as I mentioned in my previous video, any one of these are all related files. You can see here .maven. These are all Gradle related files are these four with this Gradle file. So any one of the build tool will be there. Now if I go to tasks, same thing what I done before. See the build and build task. I need to run with under the build category. There is a build. If I run it, it will launch the terminal and it will create a outcome of the project. Now in the previous video what I saw is Maven is the build tool which is going to create a target folder. You see a target folder is still present, and within the target folder entire outcome is present. Now the Gradle is going to create a folder called build. So you see the build folder. This build folder is representing a Gradle output. So if someone asks what is the output for the Gradle build tool, it's going to be sitting inside build folder. So being it as a outcome of the project, being it as a test report or JUnit report. So if you don't know what is a JUnit is basically along with the while writing a program, while writing a code, developer itself he writes some kind of logic which will tell uh, the functionality is working fine. That's what the JUnit is referring to. So when developer is writing the code, he will write two logics. One logic is actual functionality. Another logic is just for testing that logic, whatever is written, whether it's working or not. That's called JUnit. So if you go to SRC folder, you have a main where they write the entire main logic, and the test folder where they will be writing all the test cases. So if somebody is writing any developer is writing a main code, that's their responsibility to integrate and add test cases along with their main code as well. So this how basically developer works. So now if you go to build folder, you should see a libs folder. Inside libs we have London weather jar 1.0.0 hyphen plain.jar. I think London. Let me clear this folder and let me build it again rather than delete the build folder. So if I delete build folder and target folder, the target is an outcome, right? Target is an outcome, build is an outcome. If you see, this is the project code. Mainly SRC is the main project code, and all other things, whatever we have here, it's all related to how to build the project. So only the main project code is sitting in the SRC folder. Yeah. So now I'm going to run the build command again. So this is going to generate a build folder. Within the build folder, you will be having libs. Within the libs, we have a London weather.jar file. Let me run. We do have another file as well. Probably, I don't think, let me have a look in the build.gradle. What is the outcome of the file which we are expecting? If you see build.gradle, the outcome of the project, what I'm expecting is it is having 1.0.0 version inside. Yeah, this is the outcome. bootJar, London weather.jar file. This is an outcome which is going to generate as part of the Gradle project. So a Gradle, yeah, within the same project, we are using Gradle build tool, which is going to generate this file, whatever I'm highlighting, London weather.jar. This is the bootable file. So what I do, I'll go to build folder. You don't need to run this terminal always in this. You can go to all, happy to go to the folder where the code is present. You can go to the folder and see the build folder. You can run the command from here as well and say, open the command prompt and just say java-jar. You need to go to lib folder as well. Libs ls, sorry, dir. You can see there are files available, London weather.jar. Just type java-jar London weather.jar. So same thing, whether you execute it from the VS Code or whether you execute from command prompt, there is no any difference. So now this is going to run the outcome of the project, and it's running again on 8080. So let's go back to the browser and just see what how it looks like. So http colon localhost 8080. You should see the same application whatever we have seen when I ran the Maven outcome. Localhost 8080. Still taking a lot of time. Let me press Ctrl C and run it again. So it is opening. Took some time to load. We refresh again. Okay, I'm just, yeah, it's coming up. Yeah, now you see it is loaded fine. So this how we kind of build it from the Gradle. So always either being whatever the build tool it is, we should be having a clarity based on the project files what we have. If it is a pom.xml, it is used by Maven. If it is a build.gradle, it is used by Gradle build tool. Right? So now let's take a step back and see what is there in the outcome. We never seen the outcome by opening the outcome and see what is inside, right? So let's see what is inside. So we return, I mean, developers written the code in the format of, human readable, where they written the in a programmatic way of the entire logic. The outcome what we generated or what we got is, if I open this file, I don't think I can directly open it. I need to use, let me see, open with 7-zip. Let me install quickly 7-zip in my system. Within the build folder, libs, I think I have open with 7-zip, open archive. If we see, you can find all the files, whatever the project outcome we have, that entire thing is here. And if you see boot info, all the booting related stuff, all the startup related stuff is in the boot info, and the main code is sitting in the, sorry, my bad. I think it includes everything, and within this we will be having both bootable related stuff, whatever the stuff is required for starting up, and also whatever the code which we have written. So, I mean, in the project. If I go to SRC, in SRC main Java, you can see controller Java com London weather. This is the structure what we have, com London weather. Let's expand this and see what we have. In the classes, you see com London weather. Within this com London weather, we have a controller model service and also we have a class file. See here, controller model service, we have a class file. So what is this class? You see here, we have a Java file. In the outcome, we got a class file. So class file is something, a compiled version of the same file, which we can't really see what is inside. You see here, this is how the file look like, the class file. So class file is a compiled version of the same file, whatever we written in the Java. So in case if you want to see what is inside, then obviously I would say we have a decompiler. We need to do decompilation, then we will get a original file out of it. Yeah. So that's how we basically at any time, in case if you want to see whether the file, whatever I written it, the file, what is there in the jar file, is it same or not? Those are the cases people prefer it, but majority of the cases we don't really require. There are a lot of other options which we can use it to prove whether your code or the outcome is same or not. Yeah. So that's how we basically open the file and see. Suppose, for example, if you introduce a new Java file, whether you want to verify whether it is there or not, you can verify by going into the location and see there should be an equivalent class file. Obviously, this class file, this entire outcome, whatever, entire content, whatever is there inside, it should be there in the build folder as well. If I open a build folder, you see classes, you can see the main the class file. So whatever is gone inside the jar file, everything is there in the build folder. Okay, that's how we basically generate the outcome by using a Gradle and run it and get it tested. Once it is being tested, then uh, people push it to centralized location. So imagine that, this is one of the developer where he's developing the stuff and he tested, say for example, we have a website here, and if you need a drop down, the developer will edit the code and in such a way that drop down will come. He will test it by generating outcome Maven or Gradle, and he will do java-jar, get it tested. Once it is tested, he will go to the browser. I mean, from the browser, he will verify it. Once it is all done, then he will push the code into centralized location where this code can be maintained. Then let's see what is the centralized location, how this can be kind of pushed into centralized location. This scenario, whatever we covered, Maven and Gradle and build and run it, it is purely one developer perspective. You assume that you have one developer where this particular developer generated the code, is using Maven and Gradle or either one of this tool, Maven or Gradle, and how to compile the code, how he will run it and test it. That's what we see today. Yeah. Thank you for watching. I hope you like the video. Thank you.